Hello everyone, how are you all? Hope you are all doing well. So welcome back to our channel, your favorite channel, our beloved channel Chemistry with RK. So yes, for IIT-JEE students, those who are going to give attempt in the January 2024. So this particular course, bullet course, will help you, will take you to the next level in your preparation actually. Okay, so yes, we have so many books, we have so many materials, but none of the material will be giving a perfect explanation for all the previous year JEE questions. So with the students request, I have decided to start this bullet course on the atomic structure as far as present lecture is concerned. So next in the coming few days, we are going to see, or we are going to solve more number of questions in different chapters. Okay, right. So without any late, let me go with the lecture. But before that, please, I request you to subscribe to my channel and don't forget to click on the bell icon to get the regular updates. Yes, I have been getting continuous encouragement, continuous support from all of you, but still I want some more support from your. As I have told you in my previous lecture, I will be available in WhatsApp also. So many of the students have been utilizing that particular option. So if you are new, so please try to make use of this particular source. So this is my WhatsApp number, and then I'll be available. So anyway, we need to have at least one source to contact a person, right? Or else you can also email. This is the email you need to chemistry with rk@gmail.com. Yes. Okay. Here I will be available. I will be responding to your queries, responding to your doubts, or any kinds of even if you want prepared notes, like whatever I'm going to explain here, if you want them in the prepared notes form, so you can just WhatsApp me, so I could able to send you. Okay. Yeah, let's move on to our first question. So the question is, consider the following pair of electrons. So for them, they have given N, L, M, S values. Principal, azimuthal, magnetic and spin quantum number values they have given. 4 options they have given. And the pair of electron present in degenerate orbitals are. So first of all, what do you mean by degenerate orbitals? So if you observe carefully, degenerate orbitals are nothing but, so just degenerate orbitals. Yes. So what do you mean by degenerate orbitals? So actually degenerate orbitals are nothing but the orbitals which have same energies. Yes, so generally the orbitals which have same energies. So how do we define energies for orbitals actually? Okay, so if you observe carefully, we have subshells. Okay, so what are the subshells we have? And then let us talk about the orbitals. So yeah, if you talk about the subshells particularly, then we have S, P, D and then F. Okay, and then for S subshell, how many orbitals we see? 1. And then for P, we have 3, and actually what are they? Px, we can see Py, and then we can see Pz. Similarly, if we look at the D subshell, we have 5, which are dxy, dyz, dzx, dx square minus y square and dz square, right? And then similarly, if we move on to F, F subshell has 7 orbitals. So which are F, we have 7 orbitals of F, right, which are actually not that easier to remember. Actually, no need to remember them. So yes, from this what we can understand, we have 3 orbitals in P subshell which are degenerate with each other. Yes, this is the point, key point here. So what are degenerate orbitals? The orbitals which have same energy. So in P subshell we have 3 orbitals which are degenerate. So Px, Py, Pz, all of them have same energies. Similarly, if we move on to D subshell, we have 5 orbitals which are dxy, dyz, dzx, dx square minus y square and dz square. They are degenerate with respect to each other. So which mean they are all having same energies. So the orbitals which belongs to the same subshell will have same energies, so they are called as degenerate. So keeping that point in mind, so just have a look into this. So if you observe the first option, in that there is A, n is equals to 3, they have given principal quantum number value, and then L is equals to 1, which is nothing but P subshell. So in A they have given 3P, fine. And then within the same option, B is third shell, and then L is equals to 2, so it is D. So obviously these two are not degenerate if you observe. I hope you understood. If you move on to the second option, in the first one they have given n equal to 3, L is equals to 2. So L is equals to 2 for D subshell. And then similarly within that, if you look at, yes, the second one also they have given third shell, and then L is equals to 2, D, yes. So this must be our answer. Why, sir? Because yes, the electrons are present in same shell and same subshell. So yes, this must be the answer. Yes, the official key also they have given option B. I hope you understood. So just look at the C also. Let us see the C also. So we have fourth shell, okay, we have fourth shell, and then L is equals to 2. So 4D we have. And then if you look at the next one, 3D we have. So obviously the orbitals are not degenerate because they are in different shells. Okay, they are in different shells. Yes, the subshells are same here, but the shells are different. So then we can't assume them as degenerate. So the pair of electrons present in degenerate orbitals must be the second option. Yes, official key also given B. Okay, hope you understood. Yeah, next let's move on to the next question. So the energy of 1 mole of photons. Yes, here let us see some equations related to this. Actually we know that from Planck's equation, E is proportional to nu, that is frequency. Energy of an electromagnetic radiation is directly proportional to frequency of the radiation. And now to remove this proportionality symbol, we need to include some constant, and the constant is very famous, which is called as Planck's constant, where the H value actually we have, that is 6.625 into 10 power of minus 27 erg second. And then if you observe 6.625 into 10 power of minus 34 joule second. Yes, these are the two values generally we use in the calculations. We can able to write down this nu is equals to C by lambda. So if you substitute into that equation, we are going to get E is equals to Hc by lambda, very important equation. And then further we also know that 1 by lambda ke place mein we can write down nu bar, which is a wave number. So if you substitute this value into this, again we are going to get E is equals to Hc 1 by lambda in place. So we can write down nu bar. Yes. So these three equations will help us to find out, the energies, or maybe frequency, maybe wavelength, and then wave number for any of the given questions. So keeping these equations in mind, just let us conclude few points here. So we can write down, since all the three equations represents or defines about the same energy, so we can write down E is equals to H nu, which can also be written as Hc by lambda, which can also be written as Hc nu bar. Yes. And now just by writing this equal and Planck's constant, which is actually a constant, and then we can able to write down the proportionality constants. Yes, energy is directly proportional to frequency, and it is inversely proportional to wavelength, and it is directly proportional to wave number. Yes. And now if we try to take the ratios of two energies, two frequencies, two wavelengths, and then two wave numbers, then we can write down, that is E1 by E2 is equals to nu1 by nu2, which can also be equals to lambda 2 by lambda 1, since it is inversely proportional, and then nu bar 1 by nu bar 2. Yes. So we can use any of these equations to solve actually. Yes, there are a few questions in the next coming slides to use these particular equations, and then we can able to get the answers. Okay, and now let us just try to understand the question first of all. So what is the question actually? So that is the energy of 1 mole of photons of radiation of wavelength. Yes, they have given Planck's constant value, Avogadro number value, and then velocity of light value also. So what is the suitable equation here? If you observe energy, they are asking energy to calculate for 1 mole of photons. Actually we know for 1 mole, whenever we have the case of 1 mole, we need to multiply the Avogadro number. Yes. So yes, here you can see the equation, that is E is equals to, okay, so just let me take this. Yeah, E is equals to hc by lambda we have, but for 1 mole they are mentioned clearly, so the equation will become, okay, yes, E is equals to hcNA by lambda. Right, so if you observe, let us take the values here. First we have to write down the given data, like whenever we have a problematic question like formula based question, so if we can able to write down the given data, then it will be easy, so it will take us to the answer. So let us not worry about the option, let us not worry about the answer, like which could be the answer, like don't worry about all those things, just you try to bifurcate, try to separate the given data so that you can get the answer finally, yes, by doing necessary calculations. Okay, so first let us take, that is the given data. So what is the given data here? So they are asking us to find out the energy, that too if you observe carefully in the options, all of them are given in the joules. Okay, all of them are given in the joules. So okay, so next Planck's constant is 6.625 into 10 power minus 34 joule second. Yes, this is what we need to take. And then the Planck's and the velocity of constant value they have given as 3 into 10 power 8, 3 into 10 power 8, 3 into 10 power 8 meter per second. Okay, fine. And then actually they have given here 6.63, so we can take it 6.625 also. Since they have given 6.63, we have to take that. And then wavelength they have given 300 nanometers. 300 nanometers if you observe, yeah. And then 300 nanometers we need to convert it into meters, so that will be 300, okay, that will be 300 into 10 power minus 9 meters, which can be written as 3 into 10 power minus 7 meters. So now keeping the equation in mind, that is E is equals to hc into NA by lambda. Okay, and now if you substitute the values in that, the equation we are going to get, it is E is equals to h ka value, that is 6.63 into 10 power minus 34 joule second, and then 3 into 10 power 8 meter per second, and then it is 6. So what they have given, if you observe, that is 6.02. okay, 6.02. Generally in most of the cases they will not give the Avogadro number value. We need to remember that 6.023 into 10 power 23. Okay, 10 power 23. Okay, if you observe, they have given here the value 10 power 23 and then they have given mole inverse. Okay, and then divided by 3 into 10 power minus 7 meter. Okay, so if you observe, meter get cancelled, second gets cancelled, and then we are going to get joules. Okay, let us finally convert it into kilojoules. Let us not worry about that. And then here 3 and then 3 also gets cancelled. So finally we are going to get 6.63 into, there is something else here also, there is 6.02 10 power minus 34. So 10 power 23 into 10 power 8 come out as 10 power 31, 10 power 31, and then this goes into the numerator, 10 power plus 7, 31, and 10 power minus 7 it will go into the numerator, 10 power plus 7. So 10 power minus 34 is here, and then 10 power plus 38 you will get in the numerator. Don't forget we have joule mole inverse, 6.63 into 6.02. So how much it is? 39.91. Okay, so let us go back to our 39.91. so we have got 39.91 into, so how much is the remaining? 10 power 4 joule mole inverse. So we can write this value as 399 into 10 power 3 joule mole inverse, right? And then 399, so this 10 power 3 we can also write it as kilo. So it is 399 kilojoule per mole is the answer. If you observe in our option, so where is that answer? Yes, this option C. Yes, the official key also given by NTA is C. So 399 kilojoule per mole is the answer. Hope you understood. Right. So yes, if you have any kinds of queries, please do ask me to comment. Yes, I'm going to give you my own notes or any of the separate materials we have. I have collected so many materials for a particular concepts. So if you can able to just WhatsApp. This is my WhatsApp number. Yes, I have been getting so many messages in WhatsApp. So sir, please could you able to send this chapter notes, that chapter notes, or any collection of formulas? Yes, thank you. I can see huge interest in that particular. So my WhatsApp number is 5995999086664, or you can also email to me to my email ID, that is chemistry with RK. Okay, yeah, chemistry with RK@gmail.com. Okay, right. And then next let us just look at into this question. Yeah, the question is the pair in which ions are isoelectronic with Al plus 3. Yeah, first of all, what are isoelectronic species? Okay, so isoelectronic ka meaning kya hota hai? So iso means same, we know very well. Same number of what? Electrons. Yes, the chemical species which have same number of electrons are called as isoelectronic species. Okay, yes, if you observe, the question given is Al plus 3. So before talking about Al plus 3, let us talk about aluminium. Yes, aluminium atomic number is 13. The total number of electrons we have are 13 electrons. But if you observe, the question given is Al plus 3, where this plus 3 charge represents the 3 electrons have been lost by aluminium actually. So by that we can say it has only 10 electrons. So Al plus 3 has 10 electrons. So similar to Al plus 3, which of the following option is having the same 10 electrons they have given? Yeah, if you look at Br minus, actually the atomic number of bromine is 35. So it will have actually bromine has 35, Z is equals to 35. So it will have 35 electrons, but Br minus they have given. So obviously it is going to have 36 electrons, which is equals to, which is similar to krypton, which is similar to krypton atomic number. So next Be plus 2 they have given, Be plus. Actually we can violate this particular option, because here we have got aluminium में हमको 10 मिला है, पर अभी इधर 36 मिला है. So obviously we can avoid it. So obviously first option is not our answer. And if you move into the second option, that is B, Cl minus they have given. Again Cl minus is Cl has 17 electrons, Cl minus have 1 electron gained, so it will have 18 electrons. Clear? And then obviously this is also not our answer. And then moving to the sulfur minus 2. So sulfur minus 2, sulfur is 16 minus 2 charge, so it has gained 2 electrons. So it will become 18, but aluminium has 10. So obviously this is also not our option. So obvious ultimate answer is our D, that is O minus 2. Oxygen has okay 8 electrons, and then O minus 2 have 10 electrons. Similarly, magnesium has 12 electrons, but magnesium plus 2 has 10 electrons. So like Al plus 3, O minus 2 and Mg plus 2 will have same 10 electrons. So I have selected all the atomic structure questions asked in different 2022 June attempt actually. Okay. Yes, let us move on to our next question. So the minimum energy that must be possessed by photons in order to produce photoelectric effect with platinum metal is. So what exactly the photoelectric effect defines about? So if you take a metal, so on the metal surface, yes, the electrons are generally distributed on the metal surface, on the core of the metal, yes, okay. And now suppose, let's say, if we give some amount of frequency or energy or wavelength, then obviously we expect this electron to go out, okay. So yes, so if you observe, yes, whenever we give some suitable amount of energy or frequency, the electrons which are present on the metal surface will just go out. So that is nothing but photoelectric effect. So how to define it exactly is the phenomena of ejection of electrons from the surface of a metal when the electron is hit by, or when the electron is given, or when the electron is irradiated by the suitable amount of frequency or energy or wavelength, then the electron will go out from the surface, which is nothing but photoelectric effect. And the electrons which are ejected from the surface is said to be photoelectrons. Okay, and then next, if you observe carefully, they have given the minimum amount of energy. Yes, actually we define the minimum amount of energy required by a metal to pull out an electron from the metal surface, which is nothing but threshold energy. The threshold energy can be written as E is equals to, or W naught is equals to H nu naught. So where this E naught, we can also write down W naught as E naught also. These two are called as work function or threshold energy. Both of them are same. Okay, work function and threshold energy are same, which can also be written as E naught is equals to H nu naught. And now what they are asking here, the minimum energy that must be possessed by. So which means that they are asking nothing but the threshold energy itself. So the given data, if you observe, so this is actually the required equation to solve this question. So if you observe carefully, they have given the threshold frequency also. What is actually nu naught? Generally nu is nothing but frequency, nu naught is the threshold frequency. So if you observe, that is E naught is equals to H value, they have given it as 6.6 into 10 power minus 34 joule second, and then they have given the threshold frequency value as 1.3 into 10 power 15 second inverse. So we can cancel second inverse and second inverse, and just we will be left with 6.6 into 1.3 into overall. So if you observe carefully, 10 power minus 34, 10 power 15. So we are going to left with 10 power minus 19 joules. So if you multiply 6.6 into 1.3, we are going to get, so let us just solve this here. 6.6 into 1.3, 6 3 is 18, 6 3 is 18, 19, 1 6 is 6, 1 6 is 6. So 8 and then 15 and then 8. So how much we are going to get? So that will become 8.58. So it is, yes, exactly here we have. So that is 8 okay. So we have 8.58 into 10 power minus 19 joules. Clearly we can see here the answer, which is a very easy one. I hope you can feel that easiness in the question. So that is going to give us answer 8.58 into 10 power minus 19 joules. Right? And then next, let's move on to our next question. Yeah, if the radius of the third Bohr orbit of hydrogen atom is R3 and the radius of fourth Bohr orbit is R4, then we need to give some relation. So it is so easy to understand. The question is actually very easy based upon the radius. So we have radius of the nth orbit. Okay, so we have the formula radius of the nth orbit. Yes, what it is? So radius of the nth orbit, we generally represent it as Rn. So which is nothing but 0.529 angstroms into n square by z is the equation we have. Okay, so if you observe carefully, by using this particular equation we can able to solve our question. So from this there is a relation between R3 and R4. So let us just try to write down. So if you observe carefully, we can write down that Rn is directly proportional to n square by z. Hope you understood. Yes. So this is a relation between principal quantum number and atomic number. Yeah, for two radius, for third Bohr orbit and fourth Bohr orbit, we can write it as R3 by R4 is equals to, it is directly proportional to principal quantum number, so we can write down N3 square by N4 square into Z4 by Z3. Okay, yes, this is the equation we are going to get here. By using this particular equation, we can derive. So for third Bohr orbit, they have given R3, and for fourth Bohr orbit, they have given R4. And then for N3, that is for the third shell, we need to take it as 3 square. And then for the fourth Bohr orbit, we need to take 4 square. And then anyway, the atomic number is same for both the cases, so we need to take 1 and 1. So, and now that will take us to the R3 by R4 is equals to 9 by 16, which can also be written as, there is a relation here between R4 actually. So from this particular equation, we can write down R4 is equals to 16 by 9 times of R3. Yes, if you observe, 16 by 9 times of R3. So where is the answer actually? R4 is equals to 16 by 9 R3. Yes, official key also given by NTA is B. Okay, hope you understood. Yes, and the next, moving into the next question, the radial and angular nodes for the 4D orbital. For the 4D orbitals, we need to find out the radial nodes actually. So what do you mean by radial nodes? So radial nodes generally represent as, we generally represent this radial nodes. Actually, they are also called as spherical nodes. Okay, so instead of asking radial nodes, if they ask spherical nodes also, we need to take it as n minus L minus 1. That is the formula. So for 4D subshell, they have given what could be the n and L values. N is equals to 4 and L is equals to, actually for D subshell, L is equals to 2. So if you substitute the value in this, that is 4 minus 2 minus 1, which is going to be 1. So the radial or angular nodes are actually 1. And then we have something else also, angular nodes also. They have asked angular nodes also. So for angular nodes, generally we define it as azimuthal quantum number L value. Okay, and now as we have discussed, for D subshell L value is 2. So L is equals to, or angular node is equals to 2. So 1 and 2 is the answer. Radial nodes are 1 we have got, angular nodes we have got 2. So the official key also given A, and we have got our option also A. Thank you. And then next, move on to the next question. If the uncertainty, yes, this is related to Heisenberg's uncertainty principle. Yes, let us just discuss the concept related to that. So, yeah, Heisenberg's uncertainty principle tells us that it is impossible to determine the change in position and change in momentum simultaneously for a fast moving fundamental particle like electron. So that conveys that, we can able to write down that is delta P into delta X greater than or equal to h by 4 pi. Yes, this is actually the equation we have for Heisenberg's uncertainty principle. If you observe carefully, if the uncertainty in velocity they have given, and then position they have given, okay, two values they have given, but here velocity, so in order to convert that into velocity, we need to take this delta P as m into delta V, which is mass into velocity. Okay, yes, in place of delta P we can write down m into delta V, and then we have delta X also greater than h by 4 pi. Yes, if you observe, and then we have to calculate the mass of the particle in grams. The mass of the particle in grams they have given. So we need to calculate the mass. So we have to send the remaining terms into the denominator. So finally we are going to get mass of a particle in grams. We need to calculate the value in grams. That is going to be equal to h by 4 pi into delta V into delta X. So this is the final equation. Yeah, by substituting the values, we are going to get here Planck's constant value we have, that is 6.626 into 10 power minus 34 joule second, and then we have a denominator 4 into pi value is 3.14, and we have velocity value they have given it as 2.4 into 10 power minus 26 meter per second, and then we have something else also, that is position. Uncertainty in the position they have given 10 power minus 7 meters. So we can cancel out here seconds and seconds, and then anything else to cancel? No. Okay, let us just wait for the next step. So if you observe, that is 10 power minus 34 joule, and then in the denominator we have meter square. Okay, so meter into meter, meter square, and then you can write down the 6.626 into 10 power minus 34 joule. We can write it as kilogram kg meter square per second square, divided by, we have 4 into 3.14. Okay, let us just calculate the value of this. So that is 4 into 3.14 into 2.14. We have got it as, so how much is the value? That will be 30.144. 30.144 into, so we will be left with 10 power minus 26, 10 power minus 7, minus 33, and then we have in the denominator meter square. Okay, so if you observe, meter square will get cancelled, and then if you observe again, okay, let us just take, no, here the second will not get cancelled actually. So these two will get cancelled with the second power minus 2. Okay, and then we are going to left with only kilogram. Okay, and then let us take this 10 power minus 33 into the numerator, 10 power plus 33. So 6.626 by 30.144. Okay, 30.144. 6.626 divided by 30.144. So how much it is? 0.21. So 0.219. Let us take 0.219. So is there any answer like that? 0.219 into 10 power minus 1 kg will be the remaining number. So we can also write it as 21.9 into 10 power minus 3 kilogram. So in place of kilo, we can write it as 10 power 3. So 10 power 3, 10 power minus 3 will get cancelled. The nearest integer we are going to get is 22 grams. Superb. So we have got the mass, the closer value will be 22. So they have given also 22. Yes, we have got our answer. So hope you understood the calculation. We have to be a bit patient. Okay. And the next question is related to quantum numbers. The number of they have given NLM values, okay, and the number of correct sets. How many? The number of correct sets. So among the A, B, C, D, we have 4 sets actually. Among them, how many are correct actually? Okay. So if you observe carefully, the first option they have given here is n is equals to 3. And then L is equals to 3. L is equals to 3, N is equals to... See, never ever N and L will become equal. So obviously, we have to cancel that. Because in third shell, we don't have... Actually, if you observe carefully, we have, third shell. So if it is N equal to 1, 2, 3, and then third shell mein humko 3 subshells hoga, S, P, D. That's it. For S, the L value is 0, for P, L value is 1, for D, L value is 2. But they have given L is equals to 3. So always you try to understand that N and L never become equal. Always L will be less than. So we can able to deduce few points here. N and L will not be equal to each other. And then always remember N is greater than L. Always, yes. What are the possible L values for a particular shell beta? That is, N could be anything starts from 1 to infinity, 1, 2, 3, anything is possible. But when it comes to azimuthal quantum number, then it must be from 0 to N minus 1. What are the possible L values? So it starts from 0, 1, 2, 3, and then so on till N minus 1. So obviously we are going to get for L value must be less than N value. So obviously the first option is the wrong one. Second option, what is the second option? So for the third shell, L is equals to 2. What is L is equals to 2? That is D. For third shell, L is equals to 2 is possible. Yes. And then if L is equals to 2, then what are the possible M values? Minus L2 plus L including 0. So obviously in between plus 2 and minus 2, we have a minus 2. So obviously this is right. I mean, second option is the correct set. And then next, moving into the third one, in second shell we have, that is P. 2p is possible. Yes, in second shell we have s and p. So 2s and 2p is possible. When L is equals to 1, what is the possible m value? Yes, from minus 1 to plus 1. So plus 1 is also given. So this is also correct. And then final D, if you observe again the n and L values, they have given same. So obviously wrong. So how many sets are possible? Correct sets here, B and C. So option is 2. So the NTA is also given option 2. Thank you. So this is very important concept in the atomic structure quantum numbers. Yes, soon I am going to give you that quantum numbers concept also. And the next, again it is related to work function of a metal. Again they have given. So maximum wavelength they are asking, maximum wavelength of a photon required by. Okay, so for this we need to take again the same equation, work function. What is that work function? I have given you in the previous few questions back. We have solved one question related to work function, that is actually E naught, or we also write it as W naught is equals to H nu naught. In place of nu naught we can also write down C by lambda naught. So finally we are going to get W is equals to Hc by lambda naught. They are asking the lambda, that is threshold wavelength they are asking, and they have given work function, that is E value. So if you substitute if you write down the given data first. So given data, what is the given data? E naught value they have given it as 6.63 into 10 power of minus 19 joules. And then H value anyway we have, that is 6.63 into 10 power minus 34 joule second. And then C value we have, that is 3 into 10 power 8 meter per second. And then anyway lambda naught we need to calculate. So just if you take the help of the formula, that is 6.63 into, substitute the values, 10 power minus 19 joules is equals to H ka value be same, 6.63 into 10 power minus 34 joule second, and then it is 3 into 10 power 8 meter per second divided by lambda naught. Yes, if you substitute, yes, 6.63 cancel, joule cancel, second divided by, there is a meter per second, second also cancel. So we are going to left out with lambda naught is equals to, what is the value we are going to left out? 3 into 10 power minus 34 into 10 power plus 8, and then this comes into the denominator and moves into the numerator, which is going to be plus 19. So finally this 10 power minus 34 plus 19 plus 8, how much it is? 10 power 27, and then 10 power minus 34 also we have. So if you observe carefully, how much is the remaining number here? 3 into 10 power minus 7. So 3 into 10 power minus 7, actually this has come in the meters. The answer we have got in the meters, but they are asking in nanometers particularly. So to convert into nanometers, 3 into, okay, so to convert this into nanometers, we can write down 300 into 10 power minus 9 meter, which can be written as 300 nanometers. So if you observe the option, yes, the answer is 300 nanometers. Hope you understood. Yes, all these are formula based questions. And then next, again we have a question related to quantum number. Yes, as I have told you just now, principal quantum. Consider the following statements. Principal quantum number possible, the principal quantum number is a positive integer. Yes, we have n values possible from 1, 2, 3 and then so on till infinity. Yes, it is correct. Azimuthal quantum number L for a given principal quantum number can have values from, so how many we can have? 0, 1, 2, 3 till n minus 1, but they have given n. So this is the wrong statement. And then observe the C, that is magnetic orbital quantum number ml for a particular L will be is equals to, yes, superb. Okay, so what does it mean is ml values we can also for a particular azimuthal quantum number. So what I mean to say is, what are the possible m values for s subshell? Actually for s subshell L value is 0. So if you substitute that particular L is equals to 0 in this formula. So 2 into 0, okay, so we can able to write it as 2 into 0 plus 1. So for S subshell, how many M values are possible? Only one, that is actually 0. Okay, and then if you observe for the second one, that is P subshell, for P subshell, if you observe 2 into 1 plus 1, because L value for P subshell, for S subshell it is 0, for P subshell it is 1, so overall we are going to get it is 3. So what are they? It is minus 1, 0 plus 1. And then for D, it is going to be 2 into 2 plus 1, which is going to be 5. So it is minus 2, minus 1, 0, plus 1, and then plus 2. Yes. So this particular formula suits this particular equation. Yes, obviously we can say option C is the correct one. And the next D, plus and minus half are two possible orientations of the spin. Yes, obviously correct. And then for L is equals to 5, what is L is equals to 5 actually? L is equals to 0 means yes, L is equals to 1, L is equals to 2, L is equals to 3, L is equals to 4, and L is equals to 5. So S, P, D, F, G, H, maybe H. Okay. So if you observe L is equals to 5, actually we have one orbital in the S subshell, 3, 5, 7, 9, 11. So it could be 11 actually, but they have, for L is equals to 5, there will be a total of 9 orbitals. This is going to be wrong. So they have given which of the above statements are correct. What are the statements correct, beta? A, C, D. So A, C, D, no, A, C, D, yeah, only A, C, D are correct. So the official key also given by NTA is, yes, C. Hope you understood. Yeah, this is what we need to do for the quantum numbers. And then again we have which of the following statements are correct. Okay. So for chromium we have chromium actually it is given atomic number 24, and then it is going to be argon. It has anomalous configuration 4s1 3d5. 4s1 3d5. The magnetic quantum number, yes, this is going to be the correct one because they have given argon 4s1 3d5. Yes. See, don't think that they have given 3d5 first and then 4s1. It is not like that. Yes, it is possible. It is correct. Okay. And then the magnetic quantum number may have a negative value. Yes, obviously correct, because magnetic quantum number generally it varies from minus L to 0 to plus L, right? So it has a possible negative values also. And then in the ground state of an atom, the orbitals are filled in order of their increasing energies. Absolutely correct. Yeah, Abbo's rule tells us that, the filling of electrons takes place in the increasing energy order. Yes, this is correct. And then the total number of nodes are given by n minus 2. No, I have asked the correct statements. So the A, B, C are correct. A, C, D, A, B, C. Yes, this is going to be the right answer. Yeah, they have given also the same order. Yes, and then next let us move into our, this question is related to Schrodinger's wave equation. Yes, if you observe carefully, in June attempt 2022, they have covered almost all the concepts of atomic structure. So, in one session they have given question related to Bohr's theory. In other session they have related question to the photoelectric effect, Heisenberg uncertainty principle, angular nodes, radial nodes, and then photoelectric effect, and then related to Planck's quantum theory, and then quantum numbers, and then now finally, they have given question related to Schrodinger's wave equation also. They have given that probability density correct plot actually. So if you observe, actually we have, psi, which is actually probability density, probable density. So what exactly it defines actually? Okay, actually this psi can have both positive and negative values. Okay, so it can have positive, 0 and negative values. But if you try to take the square of this, even the negative value will come out as positive. So psi square, they have asked with respect to psi square and then r. So only the values we need to have are positive values. So obviously, keeping that point in mind, we can just take out this particular option because the graph has went down into the negative axis they have got. So this is not our option. And then the option should not be this one also, because we have 2s. For 2s, what is the possible radial nodes actually? So n minus L minus 1, this is going to be 2 minus 0 minus 1. So there is one node. So for 2s subshell, there is one node, but in the first option we don't have any nodes. Okay, actually the node is nothing but the a point at which the electron density is 0. So here there is nothing like that. And then the option is among B and D. So if you observe the first B option, there is a node, one node is observed in this particular B option, whereas in the D there are two nodes, but we have got one node, so obviously the suitable answer for this. Yes, and there is one more point, since psi square versus r we are drawing, so we are obviously going to get the positive values only, so positive x-axis only, so the graph should not come down. So psi square versus r, if you try to draw, the graph should not come down. So here we are going to get one node, but if you see in the fourth option we have two nodes. Yes, with this I am going to end up, and then in the coming lecture I am going to come out with some other, actually I have selected all the questions from June 2022. Coming video we are going to see some other session of 2022, and then we will try to sort out all the questions of atomic structure. Yes, we are going to get some other chapter questions also. Yes, please just wait for those videos, and then please I request you to subscribe to my channel. Yes, I would like to accept your suggestions. I would like to invite your advices. Yes, if you want some other chapter to discuss from my side, please do comment your query in the comment section. Yes, I am going to come out with that particular chapter also. Yes, and one more good news is I am going to start a session, for separate session, or a one shot session for the organic chemistry. Okay, organic chemistry question solving session. I'm going to take it separately. Yes, thank you so much for watching the video. See you soon.